So this is the second topic of the second lecture. We have seen in the previous topic that we were using the formula z equals to x minus mu over sigma, and in the last topic we have verified that mu equals to mu x bar and sigma x bar equals to sigma by square root of n. I have uploaded an example where I have proved this fact. So the only difference in this topic is now we are dealing with mean. Before we were dealing with x, like here you can see before we were dealing with x, but now we are dealing with mean. So mean will replace x, so the formula will become like this. So before, the formula was x minus mu over sigma. We will replace x with x bar, because now in every problem you will not be given x but you will be given x bars. And we have verified that in sampling distribution, population mean is equals to mean of sample mean, and also standard error or so-called sample standard deviation is equals to sigma over square root of n. And if we replace these things into this formula, the formula will take this form: x bar minus mu x bar over sigma x bar, and sigma x bar is equals to this. So now when we deal with x bars, the formula takes this form. Okay, and as I have already explained in the previous slide that mu x bar is equals to mu. Okay, so everything is exactly same like the way you did your last assignment, and Tiavina and Petronola, they did excellent job. I just checked their assignments, so everything is exactly same. Now before we were given x, but now we are given x bars. So find the symmetrically distributed interval around mu will include 95% of the sample mean, where mu is 68, sigma is 15, and n is 25. So here you can see that since the interval contains 95% of the sample mean, 5% of the sample mean will be outside the interval. So like the way we did before, so this is the 95% area, so 2.5 is here and 2.5 is here. So from the standard normal z distribution, 2.5 means 0.025, and corresponding to 0.025 from minus infinity to here we have minus 1.96, and this is 95 plus 2.5, so this total is 97.25. So from minus infinity to 97.25, again you will have plus 1.96 in the z table, exactly like the way we did before. So here you can see that before, the formula of finding x was z times sigma plus mu. So everything is same. Now sigma will be replaced by sigma x bar, mu will be replaced by mu x bar, as we are dealing with x bars. Further, z times sigma x bar is equals to sigma by square root of n plus mu x bar. So this is the formula. Now you can replace the values here. We just figure out from the table z is 1.96 for upper value and z is negative 1.96 for the lower value of x and upper value of x. So we can replace the value. Mu was given 368, z is minus 1.96, sigma was given 15, n was given 25. So you can get x bar L 362, x bar occur 373. So Once again, we know mu x bar equals to mu and sigma x bar is equals to sigma over square root of n. Now we solve one more example. Suppose a population has mean mu 8 and standard deviation 3 and a random sample of size n36 is selected. What is the probability that sample mean, before it was given x, but now we are dealing with sample means, is between 7.8 and 8.2? If I look at this example from the previous topic, it should be written as find the probability that x is less than 8.2 and greater than 7.8. But now we are dealing with means, and as I said in the earlier, that there is no difference between the last topic and this topic. We are just replacing now x bar 8.2 and greater than 7.8, nothing else. Everything is exactly same, but just replace x with x bars. So even the population is not normally distributed, n is greater than 30, so we will consider it normally distributed. This is a concept, I don't want to explain it too much because we are limited to upload the slides. So here you can see that we are given mu is 8, sigma is 3, we are given n is 36, and we need to find this probability. So this is, the book is using this formula altogether, but like the way we used to do, we will continue it like that. So probability that x bar less than 8.2 greater than 7.2, so z will be x bar minus mu x bar over sigma divided by square root of n. So if x bar is 7.8, mu or mu x bar, both are same, is 8 over 3 divided by square root of n. So in that case you will get z1, and similarly you can get z2 for 8.2 minus 8 over 3 divided by 36. So you can draw the normal curve. Here you can see the normal curve. Mu is always in the center, which is 8 given. X bar 1 7.8 will be on the left side, x bar 2 is 8.2 on the right side, so we need to find area between them. So from minus infinity to minus 0.4 in the z table, you will see the area, and it will be 0.3446, and similarly from minus infinity to positive 4, you will see area in the z table, it would be 0.6554, and you can subtract this small area from this larger area, then you can get this required area like the way he did it here. So your z1 is minus 0.4 and z2 is plus 0.4.